Hello guys, welcome to a new video. In this one I'll be solving a question about probability using the sample space diagram in the context of the program IB Math AI standard level. If you happen to study this course and you need some help with probability, make yourself comfortable. This video is going to be useful to you. With that being said, follow me along on my blackboard. Here's our sample space diagram question. A math teacher designed a new type of probability game to play with her students. In the game, a student draws two marbles at random from a bag in succession with replacement. The bag contains 8 marbles, 1 red, 3 white, 2 blue and 2 green. Let me just write this real quick because I like to summarize things. So we have 1 red, 3 white, 2 blue and 2 green. And in total that gives us 8. Alright, the points scored for each colored marble is shown in the table below. So here's what we get for a red: -2, white gives us 0, blue gives us 2, green gives us 4. The score the student receives in the game is the sum of the points from the two draws. This is illustrated by the sample space diagram shown below. Let's make sense of this a bit. We have the first draw, we have the second draw. So imagine that we draw red and red on both of them. The outcome is going to be -4. Why is that? Because that would essentially be -2 plus -2, which is -4. So that works. Let's check another one. This one, for instance, blue and green. What do we get there? Well, blue is 2, green is 4, 2 plus 4 is 6. So yes, we have a 6. So basically the sample space diagram already did all this work for us. They added these scores. However, they didn't add the scores for C. And question A says determine the value of C. Okay, so C has to be the same across this diagonal, meaning that all combinations give us the same answer. Green and red, that would be 4 and 2, right? So 4 plus -2 is 2. So that means C equals to 2. I can write the answer C equals to 2. Just to make sure, I can check with another one, another combination, white and blue. White is 0, blue is 2. 0 plus 2 is 2. So indeed, we're gonna get 2 across all this diagonal. Part A is done. Then we have Lynn plays the game once. Let the random variable L represent Lynn's score. Question B. Use your answer to part A. Complete the missing column in the following probability distribution for L. So this is the probability distribution. These are the probabilities of having a certain outcome of -4, -2, 0, 4, 6, 8. These are all taken from here because this table is a reflection of the diagram above. Which value is missing? Well, 2. C was 2 and this is the value that was missing, so we need to complete the probability of having 2. That's the question. Okay, how do we do that? Well, let's see. To find the probability of getting a 2, I'm gonna solve it over here so I can see my sample space diagram to make use of it. I know that the combinations for that would be to have green and red, so I'm gonna write probability of having green and red plus the probability of having red and green, so the same thing but swapped, red and green. That's for this one. Probability, let me write that again, probability of red comma green plus probability of having blue and white. This would be this one. Okay, probability of blue and white. And of course we have to swap the places, probability of white and blue. All of these things are gonna give us the outcome of 2. So we can assume that the probabilities of each event, probability of having green, probability of having red, and so on, are independent from each other. Why is that? Because look what they say in the beginning of the question. They are taking, read this part again, they are taking marbles from the bag with replacement. So given that they replace the marbles, they put it back, the probability of each event, the probability of having either red, white or blue or green is always going to be the same, and they are given over here. So we're going to use information from this table now to figure out the answer. We're going to do the following. we're gonna have probability of getting a 2 equals to the probability of having green times probability of having red. Remember, this comes from the formula of probability A and B. Assuming A and B are independent, that's probability of A times probability of B. This formula is applicable right now over here. So I just did the first part, I just did this part, okay? And then I have to do probability of red times probability of green. And then I do the other two, plus probability of blue and white. So that's probability of blue times probability of white. And then plus, I have the last one, probability of white times probability of blue. I do all of that and I substitute the probabilities from the table. So I go here, circle it. This thing is going to help us with the probabilities. The probability of having green equals to 2 over 8, because we have 2 out of 8 green. Probability of blue equals to 2 out of 8 as well. Probability of red equals to 1 out of 8. Probability of white equals to 3 out of 8. So we have all that, and we're gonna substitute the answers over here. Probability of green was 2 over 8. Probability of red is 1 over 8. So I'm essentially going to substitute these values. I can even copy them and put them right underneath my formula so I can see them better. I'm gonna take them, I'm gonna drag them down. So we're gonna have it here, okay? I'm gonna substitute all these probabilities and finally calculate. So 2 over 8 times 1 over 8, then we are going to substitute for this one, red and green. That's going to be 1 over 8 times 2 over 8. I'm just swapping the places, plus this one, blue and white. So that would be 2 over 8 times 3 over 8. And one more time swapping the places, 3 over 8 times 2 over 8. Okay, this equals to 1 over 4. So the probability that I have here for getting 2 is going to be 1 over 4, okay? Boom. That's it. The question is done. The probability of getting a 2 is 1 over 4. We completed the table. And now for question C, we're going to make use of the table to find the probability that Lynn scores at least a 4. Alright, at least a 4, I'm going to write it over here. Probability that L is at least a 4, so greater than or equal to 4. In our case, according to the graph, according to the table, that would be 4, 6, or 8. So the probability of getting 4 plus probability of getting 6 plus probability of getting 8. And then I'm going to substitute the actual probabilities from this table. That's going to be 1 over 4 plus 1 over 8, 1 over 8 plus 1 over 16, and that would be 7 over 16. That's the answer. This was part I. For the second part, we have to score exactly 6 given that Lynn scores at least 4. So probability that the score is exactly 6 given that the score is at least 4, meaning greater than or equal to 4. So I'm going to use the conditional probability structure, and I'm going to say that this is probability of L equals to 6 and L is greater than or equal to 4 divided by the probability of the second part, probability that L is greater than or equal to 4. Now, probability that L is greater than or equal to 4 is over here. We already did, so I'm going to write 7 over 16. For the above, I have the probability that L is 6 and L is greater than or equal to 4. Well, when L is 6, it's obviously also greater than or equal to 4, so my only requirement is to look over here, which is the probability of 1 over 8. I put 1 over 8, I divide by that fraction, I do the calculation on my GDC, and I would get 2 over 7. 2 over 7 is the answer for this question. That's another one done. And finally, we are coming to a conclusion of this exercise with question D. We have over here, find Lynn's expected score in the game. So the expected score is the same as the expected value, right? I'm gonna say expected score, which is the expected value. The expected value of playing the game of the expected value of the game Lin plays, so EV of L. When it comes to expected values in such probability distribution functions, we are going to take the outcome multiplied with its corresponding probability, and we're gonna do that for each one in part and add them up. So I'm going to copy this table below so I can just use it and do my calculation. I don't want to scroll back and forth. I'm just gonna put it here, and we are going to finish this exercise. We're going to have the score of -4 times the probability of 1 over 64, so times 1 over 64 plus -2 times 3 over 32 plus 0 times 13 over 64, and then plus, and then the outcome of 2 with a probability of 1 over 4, that's what we found in part B, plus the outcome of 4 times 1 over 4, and then we have 6 times 1 over 8 plus 8 times 1 over 16, that would be 5 over 2. 5 over 2 is the final answer. This concludes our exercise. Hope this was useful. I know it was a long one, that's why you wanna go back, watch each part according to your need, okay? Hope this all made sense, and we are done.
Thank you guys for watching. If you like the video, please like the video. And if you follow this course, make sure you subscribe to the channel because it's gonna make your IB life much easier. And if you happen to have friends who might benefit from things like that, you might as well tell them too, okay? Helps me, helps them, helps you. Thank you very much for watching. I'll see you in the next one. Bye.